All right, welcome to the after work video. A little bit increasingly rare, so I'm really happy I can do it now. Let's start off the video with uploading the last one. I haven't done that yet. So it's kind of I wish I could get up an easier process for this. I thought about perhaps just doing like a live video of all my studying on YouTube, and then it would post automatically. That way I could have like a chat too. That would be like interesting in case anyone had anything to say. I wouldn't have to moderate. I wouldn't have to like do moderation on the chat while I'm trying to study though. That would suck. Okay, so I'm going to switch over to my other channel. Up to 30 subscribers. It's a big deal. Thank you for everyone who is interested in this journey of mine. Hopefully we'll start to pay off a little bit more once I take this exam, because I'll start learning material that might be a little bit more relevant to the average network professional. All right, so let's upload the last video, the lunchtime video. Okay, so we're learning about LDP tunneling. We had one video on it so far. But in that video, I unfortunately had a misconception about what topologies that support L2 circuits will look like. But I think I've got a, you know, if I think about it, I think I can come up with the right answer. So I just thought about it a little bit more. So hopefully I can make those changes. Oops. So, okay, I already have GNS3 open here. So we've got our topology here. We're just leaving that in the background for now. So let's continue on with this. They'll be back at the login prompt because the cron job will have rebooted them. Perfect. Okay, so let's get going. Okay, so now it's going to be a bit different because we're going to have a core port and a port going to the hub. Auto sensing, I've never even seen that before. But so the L2 circuit, of course, is not going to come up unless we have RSVP neighbors, and we can see that we do not. Yeah, you can't have MPLS labels neighbors. So we're going to start off right here in this next video. We're going to start by troubleshooting why we're not getting an RSVP neighbor. So let's look at the configuration with that in mind. So here's our RSVP configuration. We've got GE001, which is the port connected to router 8. And we've got family MPLS on there. We've got an IP on there. So we've got it in MPLS. So yeah, I'm not sure exactly what the requirements are to get RSVP, to establish an RSVP neighbor. Let's see if we can figure that out from the help apropos. Okay, and let's see if there's more information here, because sometimes they make it really difficult. They have extra options buried within a command. Okay. So I'm keeping an eye out for, oh, here we go. Ah, this is it. This is exactly what I need. Configuring RSVP and MPLS, perfect. The primary purpose of the Junos RSVP software is to support dynamic signaling within label switched paths, LSPs. When you enable both MPLS and RSVP on a router, MPLS becomes a client of RSVP. No additional configuration is required to bind MPLS and RSVP. You can configure MPLS to set up signaled paths by using the label switched path statement at its protocol's MPLS hierarchy level. Each LSP translates into a request for RSVP to initiate an RSVP session. This request is passed through the internal interface between label switching and RSVP. After examining the request information, checking RSVP states, and checking the local routing tables, RSVP initiates one session for each LSP. The session is sourced from the local router and is destined for the target of the LSP. When an RSVP session is successfully created, the LSP is set up along the paths created by the RSVP session. If the RSVP session is unsuccessful, RSVP notifies MPLS of its status. It is up to MPLS to initiate backup paths or continue retrying the initial path. To pass label switching signaling information, RSVP supports 4 additional objects: label request object, label object, explicit route object, and route record object. For an LSP to be set up successfully, all routers along the path must support MPLS, RSVP, and the 4 objects. Of the 4 objects, the record route object is not mandatory. Okay, so I'm just thinking maybe I don't have maybe the 3 objects, because one is optional. Maybe my routers aren't supporting those 3 objects for some reason. To enable MPLS and make it a client of RSVP, do the following. Enable MPLS on all routers that will participate in the label switching. That is, on all routers that might be a part of a label switching path. Enable RSVP on all routers and all router interfaces that form the LSP. Configure the routers at the beginning of the LSP. Okay, so maybe I'm missing some interfaces. Let's continue with the reading. So here's an example for a router at the beginning of an LSP. Yep, and this looks very familiar. This is exactly what I did. So here's an example for all other routers, for the routers in the middle of the LSP. You'll notice it's a lot simpler. You just have the interface. You don't need this extra here. One thing that might be pretty noticeable is that there's only one interface. You know, that's not going to work. It's going to have at least 2 interfaces. But it's just an example, and it makes sense. So let's test the hypothesis that, The problem is that I am missing a port from the protocol's RSVP configuration. Oops, used to doing configured terminal now. Now that I'm not working every day on Junipers anymore. Okay. Oh, so we still don't have an RSVP neighbor. You know what? I think the reason for this is because you can't form a neighbor with an end of a LSP. Let me pull up Paint and kind of explain what I'm thinking. So I think what's going on here, and I thought I opened Paint. Here we go. Okay. So I think what's going on here is we've got two routers, and here's a here's you know a point where it goes into the LSP. Here's another point where it goes into the LSP, and of course, for that matter, it goes out of the LSP as well. You know, it's a pretty simple concept of what happens on these two routers. It goes in and out of the LSP. So we don't have any routers where it goes through the LSP. So one thing to know about LSP neighborships is if I were to have an extra router here, I would have two neighborships. I would have a neighborship here and a neighborship here. So I'm thinking you can't form a neighbor with an endpoint of an LSP. You can only form an RSVP neighborship to a device that is, you know, from an endpoint of an LSP to a transit. You can't do it endpoint to endpoint. So I think that's what's going on. The good news is that's pretty easily testable. I might need to break down my topology here, but I can certainly do that. Let me see if I was using RSVP on here. Why is this lagging so much? Okay. No, I wasn't using. Okay, so I do have a L2 circuit on here, so I'm kind of tempted to just play around with this, but I think it would just get too complicated too fast for me. There's a lot of things with MPLS that I'm really not comfortable with, so kind of cranking up the difficulty to 11 I don't think is a good idea right now. I think what I'll do is I'll crank it up to 9, and then if I need a little bit extra, then I'll bring it up to 10. Okay, so we're going to test the theory now that you can't form RSVP neighborships with an endpoint of an LSP. I mean, we could test that a lot easier just by getting rid of the, let's do that because that'll be an easier way to test it. Okay, so the easiest way to test it is just to no longer make this an endpoint of the LSP. So to do that, we just be deleting this. Okay, so that didn't do it. So I'm not sure what in the world is happening right now. I think maybe this has got to be a VLAN CCC interface. Yeah. I think maybe that's what's going on, actually. Let's try that. Okay, so I'm going to roll back my configuration, and then I'm going to alter the G0001 or 001. Okay, and then I'm gonna delete this and make it a, well, actually, no, I think 000 is the one. That needs to be a CCC interface. I'm actually really confused. I don't know what's going on. I think I'm going to just try to un-F myself here and do a quick Google search. So Juniper RSVP neighbor. Yeah, so let's see if we can get just a simple example configuration for RSVP. Okay, so let's make it as easy as possible. We're going to blank out everything on these two, and then we're just going to enable that one command and see if we can get a neighborship. Okay, so we're going to keep things as simple as possible. We're going to, oh, I'm in config mode. I like configure private better. So do edit int 001. Oops, and let's even look if they want it in a, okay, so the minimum configuration to enable RSVP on a single interface include the RSVP statement and specify the interface using interface statement. Okay, so they didn't give the prerequisites, unfortunately. Okay, this is going to be better here. So yeah, here's their topology. Let's see what kind of topology they are doing here. Okay, so they're doing a path from R1 to R7. Okay, right, like that. I mean, to be honest, we could just do this setup here, and then from there do tunneling. So why don't we just do that? Let's get on the rails. Right now we're very much off the rails, and So we got 1, 2, 3, 4, 5, 6, 7, 8. We got 9 routers, but we're just going to do it with 8. And we're going to be doing this example here, and then we'll be doing tunneling. It might even have tunneling as one of the steps here. Yep, so RSVP, LSP tunnels. So here's the, in fact, let's just skip that. Oh, yeah, let's just do this one because this is the exact thing we need to do. There's no sense in doing that other one as well. So this is going to be 1, 2, 3, 4, 5, 6 routers. Okay, and I think I will delete, so 1, 2, 3, 4, 5, 6. I will delete these extra routers. It's just too much for me to work with. Oops, and I wasn't expecting that to happen. Oop, it looks like my video is now live though. That's good. Okay, perfect. So now we've only got 6 routers, much easier to work with. So we'll be deleting, yep, just hub 1. And then I'm going to delete all these links. And then I'll blank out the configurations. Okay, so one thing I'm going to do as well, let's see here. So I want to take a look at, I see. So I'm going to find the, what was it? Yeah, RSVP. Oh, that's an LSP tunnel. Okay, I wanted an LDP tunnel. Is there anything like that? All right, let's do a Google search for that. Okay, so this is going to be good to know, even though it's not hands-on. I think it's worth a read. So I'll add it to my notes. Okay, so yeah, so here's what we're going to do. So we've got this command that so this is an explanation of how to tunnel it over RSVP. So we'll do that lab, which is just a simple configuring RSVP. So this example, configuring RSVP signaled LSPs. So there's kind of a lot of, what was the other one? I thought there was another lab that was a bit, yeah, this one. Okay, yeah, this is not related to this topic. Okay, so we're going to do this lab here. And then once we're done with that, we'll just be adding the extra commands to tunnel LDP LSP over our RSVP signaled LSP. Okay, and I'm not going to follow exactly the topology they have here. They have 7, 8, 9 routers. I've only got 6 now because I deleted those 2, but those are the only I'm going to need. So using RSVP as a signaling protocol, you can create LSPs between routers in an IP network. In this example, you configure a sample network as shown in figure 1. Ours is going to be a bit different than that. To establish an LSP between routers, you must individually enable the MPLS family and configure RSVP on each of the transit interfaces in the MPLS network. This example shows how to enable MPLS and configure RSVP on the GE-0/0/0 transit interface. Additionally, you must enable the MPLS process on all of the MPLS interfaces in the network. Okay, I thought I did all that in my other one, but hopefully things go better for me here. This example shows how to define an LSP from R1 to R7 on the ingress router R1 using R7's loopback address 10.0.9.7. The configuration reserves 10 megabits per second of bandwidth. Additionally, the configuration disables the CSPF algorithm. You know what? That's probably what happened. Ensuring that hosts C1 and C2 use the RSVP signaled LSP that respond to the network IGP's shortest path. Let me just try that quick. Oh, well, never mind. I already tanked it. Okay. So first things first, I've got to blank these out. Okay, and then I'm going to name this one router 6, but I will get there when I get there. Yeah, I'm going to be really in dire straits on the test when I get to something where I can't use help apropos and I've got to use, and during these sessions, I would have done a Google search. That's going to be a really hard thing for me to realize that I just don't know what's going on. But I think the appropriate thing to do in that case is to just move on. because you can go back and forth through the sections of the test. So it's important to, don't spend all your time on question 2 and then you never get to question 3. Better off if you skip question 2, you get question 3 right, and then you got hopefully questions 1 and 3 right. Whereas if you spent all your time trying to get question 2 and you got it wrong, you would get question 3 wrong as well because you didn't have enough time for it, and you'd only get question 1 correct. Oops, this one I'm going to rename to R6. All right, so be getting rid of those annoying messages. We'll see that master go away because it's no longer configured for redundant routing engines, so it's no longer relevant for me to see that it is master because there's only one. If I do have it configured for redundant routing engines, it is very important that I see that master, because you want to know if your CLI commands are going to be applied to the master routing engine or the backup routing engine. In my case, I only have one routing engine though. But I'm actually curious if I can have more than one routing engine. I saw a blog post of somebody trying to set that up in GNS, and I tried it myself, but didn't really have much luck. But I didn't try it super hard. Definitely not as hard as I tried the treasure trove script. And I figured out how to do the treasure trove script, even though I don't think it's necessary. But usually if I try something incredibly hard, I can make more progress on it than I would have thought possible. Okay. Oh, I got to change the host name, the symbol host name as well. Ah, I got them flipped. Oh, well, that's okay. Well, no, it's not. Oh, God damn it. Okay, that wasn't too bad. Oops, forgot some extra stuff. It's kind of out of order. Perfect. Okay, everything is good to go. So, well, it's good to go to start the lab. It's not ready for the tunneling yet. All right, so let's get, this one looks pretty good. I'm just gonna save this because it looks really good. Might not necessarily do it. I'll just look it over before moving on. Okay, so this is the one I'm gonna be doing. It's the, yeah, this one. Okay, so to quickly configure, yep. So this is going to be on the endpoints. So, oh, well, usually it doesn't leave you quite this high and dry, because usually it will tell you like what's required for these. Yeah, and the requirements before you begin. Delete security services from the device, but it doesn't tell you if you need a routing protocol, if you need anything like that. And usually it's pretty good about that in the examples. So this example is particularly bad. Yeah, like see, oh, never mind. Well, let's look at the next example here. Shoot. Yeah, it's really not being good about the requirements. So this is just an LSP from here to here. So you must individually enable the MPLS family and configure RSVP on each of the transit interfaces in the MPLS network. All right, so let's just do this. And these are all going to be transit interfaces. Let's actually do this. So we're going to put these in a full mesh. And then we're going to have all the transit interfaces. And then we'll have two connections. So it's going to be zeros on the top, ones on the bottom. Okay, zeros on the top, ones on the bottom. Okay, and then same convention, we're gonna have the lower number on top, higher number on the bottom. Something went wrong with the convention there. There we go. And now we're going to have two links like this. We'll just do the highest port for both of these. Okay, so yeah, I don't think a full mesh. Yeah, a full mesh is just too much configuration, so I'm going to leave out the links going through here. So it's not going to be a true full mesh, but this will be good enough, I think. So now we can follow along, and okay, so we can follow along now, hopefully. What was that thing again? There was something where you click once, click twice, and hit enter. It goes to the first tab. Well, anyways, let's see here. Okay, so we're gonna need this for all the transit interfaces. And then we're just gonna need this for the router 1 and router 6. So should say that up here. To establish an LSP between routers, you must individually enable the MPLS family and configure RSVP on each of the transit interfaces in the MPLS network. So this is going to be good because we're going to try to do this with as minimal configuration as possible. So the first thing we're going to do is just look at the transit interfaces. Okay, so every interface that is up is going to be a transit interface, and then we'll establish our LSP to the loopbacks on router 1 and router 6. Okay, so hopefully this is it. This is the absolute bare minimum you need to establish a RSVP neighbor, but we will find out really soon, because the first thing I will do is show RSVP neighbors. Oh, so show int terse match g dash. Oh, not MPLS. It's going to be RSVP. We won't even need protocols MPLS to be set up until we actually set up the LSP itself. This is just the signaling that is used to it's the road. We haven't set up the car yet. We're just going to start with the road. We're going to make sure our roads are nice and smooth. Okay, so I think router 3 is connected. Yep, router 3 is connected to router 1, so hopefully we'll have a RSVP neighbor now. We do not have an RSVP neighbor, so oh. All right, I'm gonna get a pillow here so that I get no damage. I'm going to very gently throw my glasses on that pillow so that no harm comes to them, and assume this position for a little bit. And then do some Google searches to figure out how to get a RSVP neighborship established. Okay, so why? Maybe I need. Maybe I do need it. Well, first thing I'm going to verify. Zoom in a little bit. Okay, so it will be between here. Maybe it does need to have MPLS. Okay, so one thing I can definitely do that will help me with all of this is a Wireshark capture. I won't have Wireshark on the test, but I will have monitor traffic. But right now I'm obviously a little bit frustrated, so I'm just going to do it the easiest way I can. The good news is I am using Wireshark, so I can add that to my tags. I know a lot of people in networking are really interested in getting better at using Wireshark. Okay, so this is what I figured. You do need IP addressing set up in order to have a RSVP neighbor, I think. Let's see what kind of encapsulations are available on the physical interface. Okay, let's try Ethernet CCC. Oh. Oh, right. Okay. Yeah, that's not going to work. So there is only the CCC family. Okay. Yeah. So it does have to be. It can't be CCC authentication. Okay. So let's try setting up an IP on there. Oops, I'll of course need to revert that. So delete and let's just do this. Rollback 0. No, commit and quit. Okay, so now .2 is going to be on the other one. Hopefully we've got the RSVP neighbor up now. The good news is we do have the Wireshark capture open. So hopefully it will start to show some traffic. There is the bug Okay, let's see if we can ping. Can't ping. Oh, I can. Okay. All right, so let's see if there's some traffic. I'm thinking the bug is happening. Okay, so I'll make sure there's going to be ICMP showing up at least. Okay, so we've got ICMP. We don't have RSVP traffic going over though, which is interesting. How do I get RSVP traffic to go? What am I missing so that RSVP traffic can be sent? Why is there no RSVP traffic being sent? Why is no RSVP traffic being sent from my Juniper? Why is there no traffic? Why can't, does there have to be an LSP? Is that why? I swear I've seen there be traffic. Like I thought when you enable, it's kind of like I thought it was kind of like enabling MPLS, or sorry, OSPF, where there are RSVP hellos that are sent out as soon as you enable it. Like I didn't think you had to have like a LSP for there to be RSVP traffic. Like I thought that was independent of LSP. I mean, maybe I'm wrong about that. Let's try configuring an LSP and see if that's what the problem is. I'm very stumped right now. Obviously, I have a misunderstanding of this. Let me know in the comments below if you know what I am struggling with right now and how to solve it. Maybe I have to have like some routing options configured. Like I have to have a router ID or something. No, I still don't have any traffic. Oh, my order is here. So that's going to be it for now. Thanks for watching. See you in the next one. I've got an order here, so I got to bring that in. Fortunately, I didn't really get very far, but hopefully we get farther in the lunchtime video tomorrow.